This lesson is on inverse functions, and I have really big right here, switch x and y. And the reason I have it really big is because that is the main thing that you need to know about inverses, is that all the x's and y's are switched. Whatever you're doing, that can help you get started. We've already done this with some trig things. Now we're going to do this with just regular functions. We're going to do this with several different types of things. The first thing is very easy. We're going to do it with a table. So I have a table of values here of x and f of x, so think of x and y. Here's my x values, here's my y values. When I go to make a table of x and f inverse of x, all that happens is those things switch. So the y values in this one are the x values in the other. So we'll just list those down through here. Then your x values in the original are now the y values in the inverse graph. So that's how it works with a table, or if they gave you a list of points. So if they listed some points out, all you'd have to do is switch the x and the y, so those kind of fit together. Now we'll move down to what happens on a graph. And so we are actually going to use a familiar graph, y equals x squared. Okay, so f of x equals x squared. And I'm going to list some of the points on that graph. We know the point at the vertex is 0, 0. We have the point 1, 1. We also have the point 2, 4. Over here we have the point negative 1, 1 because we're symmetric with respect to the y-axis, and the point negative 2, 4. So these are just points that are on your graph of f of x equals x squared. Okay, now we're going to come over here and we are going to graph the inverse of this. And so I'm going to start here, negative 2, 4. If I switch the x and y, I have 4, negative 2. So I'm going to plot 4, negative 2. Then I have the point negative 1, 1. If I switch the x and y, I have 1, negative 1. 0, 0, obviously, if you switch those don't change. 1, 1, if you switch those don't change. And then 2, 4 switched is 4, 2. And so if we connect this is basically turning that parabola sideways. Now, the problem here is that this no longer passes the vertical line test. So this is a case where if you do strictly the inverse, it comes out to be not a function. But can you think of what we normally call the inverse of x squared? What will undo an x squared? A square root. Look at just this part of the graph. This is what I have had you memorize as the square root graph. And the reason is because when you do a square root, you have a positive and a negative answer. For example, the square root of 4 is truly positive 2 and negative 2. And so you have both of those outputs, but a lot of times when we're just dealing with functions, we just deal with the positive output for solving an equation or something. Here we're going to use just the positive outputs, which is a function if we're ignoring this negative part. And so we're going to call this graph that I've highlighted our g of x for right now, which is the square root of x. Okay, and that is the inverse of this f of x function. And again, if we just choose that top half, it now passes the vertical line test, and it is a function there. Something else that you need to know is when you have inverses, you'll notice there's a relationship. This one was facing up, this one's facing right. That relationship is a special kind of flip. You're not flipping up and down or left and right. You're actually flipping over this line right here, which is a perfect diagonal. And so when you flip this parabola over this line, it ends up here. Do you know the equation of that line? What is the equation of a line that is a perfect diagonal? And hopefully from your toolbox you'll realize that that is y equals x. Okay, that again is what happens when you switch the x and y's. You get the new graph. It happens to be a flip over this line. This is one situation. There are plenty more situations of inverse graphs that we will work with. But I wanted to work with this one and show you why a square root graph looks the way that it does and how it relates to your x squared graph. Another pair of inverse graphs that you're already working with, if you think of y equals a to the x or e to the x graph, you've learned that shape here crosses at 1 on the y-axis. This is a good one to think about. If you flip it over that diagonal line, where does it end up? And it ends up right here. You can see it really well being flipped over that line, and hopefully you know that is your log graph. Okay, so exponentials and logs undo each other. They're inverses of each other. So you can see this one as a flip a little bit better. Okay, the next kind of problem we're going to do is finding an inverse algebraically, and this is probably what you're familiar with, what you've done before. If the function is in terms of f of x, you want to think of that as y, and I usually write it down as y. Then you literally switch your x and y. It should look exactly the same except they trade places. Don't take any powers with them or anything added or subtracted or multiplied. Just switch the x and the y. Then solve for the y and make sure if it was in function notation that you change back to function notation for that last step. So I'm going to do a few examples. Start with a really basic one. F of x equals 4x. Again, think of that f of x as y. Then the next step is to literally switch x and y. So I'm going to have x equals 4y. Then I'm going to solve for y. So I'm going to divide by 4. I could write that as 1/4 x or x divided by 4. And then since this problem was given in function notation, I'm going to replace that y with f inverse, and I'm going to switch it around just so it's prettier. So that y equals x over 4, or f inverse equals x over 4. So that's the basic steps. Switch x and y, solve for y, and if it was in function notation, replace that with an f inverse. Okay, for example 2, again, think of your f of x as y. Switch your x and y. So x will equal the square root of y plus 3. You're trying to solve for y, so what do? Square both sides. So I'm going to square this and square this. That will give me x squared equals, these will cancel, and I will have y plus 3. Then I'm going to subtract the 3. So that y is going to equal x squared minus 3. And again, since this problem was in function notation to begin with, I'm going to end it in function notation. What I have found is the inverse, so I'm going to replace the y with f inverse. And here is the inverse equation. Okay, on example 3, again, I'm in function notation, so I treat it like a y. Literally switch the x and y. Do not move the minus 2. So make it x equals 5 over y minus 2. Now, you have to remember how to get rid of that fraction. You can't just like add the 2 or divide by 5 and get that y off the bottom. It's not going to happen. You have to multiply by the denominator on both sides. So I'm going to multiply by y minus 2 on both sides. It's going to cancel out over here and just leave me with 5. On this side, I'm going to have x times y minus 2. However, I'm not going to distribute. My goal is to get the y by itself. So I need to get rid of the x and get rid of the 2, not bring them together. So what you got to do next is divide by x. So now I just have y minus 2 on the left. I have 5 over x on the right. Then I'm going to add my 2. And I have 5 over x plus 2. And then again, since I started in function notation, I'm going to end in function notation. F inverse of x is going to replace my y. And my equation is 5 over x plus 2. Now we're also to the part of the lesson that might be new to you. This is a concept that we use in the upper level math for several different things. Let's read this together. If f of g of x equals x and g of f of x equals x, then f and g are inverses of each other. Okay, notice that this is not x squared or 2x. Anything other than x as an output means they're not inverses. But if I do a composition one way and get x, I do a composition the other way and get an x, then they are inverses. And this is how you test for it. So if you are given this test question, I don't want you to do what we just did in examples 1 through 3. That's not what I'm wanting you to do. I'm wanting you to check it with composition, and I want you to show both ways. So here's our question number 4. If f of x is 4x minus 1 and g of x is x plus 1 over 4, are they inverses of each other? They look like they've got some things that might make them that way, but we have to test it with composition. So we're going to do f of g of x. And you know, I like to replace that g of x with the equation for g. And then I'm going to write my f equation and leave the x out. And then I'm going to plug the x plus 1 over 4 in. Now it's important when you do this to show your work. So do one thing at a time. So for example, the 4's are going to cancel first here. That's going to leave me with x plus 1 minus 1. Then if you combine like terms, you just get x. So I got x one way, I have to do it the other way. So I have to do g of f of x. So I'm going to take out the f of x, I'm going to put in the equation 4x minus 1. And then I'm going to write my g equation but take the x out. When I take the x out, I'm going to plug 4x minus 1 in. And again, I'm going to take this one step at a time. So the first thing that happens is this negative 1 and positive 1 go to 0. So I have 4x over 4. And then my 4's cancel and I have x. Since I got x out of both, f and g are inverses. Okay, so when I ask this on a test, do not do what you did 1 through 3. You need to show these types of compositions and you need to show your work in each step. That's how you're going to get the credit for that. Okay, so 5 is basically asking you the same thing. I'm giving you an f, I'm giving you a g, and asking if they're inverses. So pause right now and try this one on your own. Okay, so hopefully the first thing you did was do f of g of x, which means I'm going to be plugging the g into the f. So I write the f equation, but where I had an x, I put the g equation in. And again, it's important that you do one thing at a time. So the first thing that should happen is the cube root and the cube cancel. That'll leave you with x plus 1 over 2 right there. Then the 2's will cancel, and that will leave you with the x plus 1 and the minus 1 from the outside. And then the plus 1 and the minus 1 will cancel each other out, and you're left with x. Then you have to go the other way. You have to do g of f of x. So I plug the f into the g. So where I had an x in the g equation, I now have the f equation of 2x cubed minus 1. The first thing that happens is the negative 1 and positive 1 cancel each other out. Then the 2's cancel each other out. Then the cube root and the cube cancel each other out, and that leaves me with x. So again, I have a situation that, yes, they are inverses. But had I gotten anything else other than plain x, if I got a 5x on one side or something like that, they would not be inverses. So if they match, they're inverses. If they don't match, they are not inverses. Your assignment for this is going to be on page 69. In 1 through 18, what I want you to do, if it doesn't already say so, is find the inverse. In 15 through 20, I want you to tell me, are they inverses? So 15 through 20, you're doing what we just did in example 4 and 5. And then you'll also do 21 through 24. Okay, so make sure in 15 through 20 you are doing all of the work that we just did in 4 and 5.